Okay, I'm gonna attempt to make now an application of the no arbitrage principle. Okay, NAP, I think sometimes people think as the no aggression principle, but this is completely different. Oh, damn. Oops. Okay, no arbitrage principle. In other words, NAP. And if you're gonna be redundant, you can say the NAP principle. Anyway, so it, it basically says no arbitrage is permitted. And one consequence of that is that if we have wait, so I think there's like this is basically going to be equivalent to the one price principle. If we have two portfolios, okay, and in a way both of them have values through time, where often the value is like if you try to have no assets whatsoever at that instant, only money, so you try to sell everything you have or execute whatever's more valuable. If you do that, um, that's the value, and there's a value at each time, right? And for example, if the way you make that money is selling, then the payoff is what if you sell everything? What money do you have at the end? Okay, and that just says that if the value at some time of a portfolio is the same is a value if at time t, okay, the values of two portfolios are equal, then at any other time before the values must be equal as well. Okay, that's basically what it means. And when you just buy it, I mean, if you buy it, you can immediately resell it, right? So the value at the time that you just bought it basically is going to be the price that you just bought it at. And in a similar way, the price at any time, the value at any time of it specifically is going to be the value that you could sell it for. Okay. So yeah. So I think this is the principle of one price. Let's just add it here. Principle of one price. Pop, I guess. I don't actually know if it's wait, I have the of. I don't know if it's poop. It's not intentional. Whatever. Whatever. Anyway, if like the value of P of A at T equals the value of P of pi of B. I'm saying P, it's pi of pi pi B of T is equal, let's say let's put big T, then for any T smaller than T we have that value of just the same basically, that their values are equal at that time. Okay, now we're gonna apply that to European options. Okay, so what I'm gonna do is I'm gonna compare a put and a call, and I'm gonna see what their value, what's the relationship between their value. Okay, and actually we can, it's not a trick, but if we already know what the value of an option at the expiration date or the maturity date, that makes things easier. So and it's pretty obvious. So the value of let's say a call at the maturity date is going to be equal to So the value, if we have the call to make money out of it, there's two options, okay? There's gonna be two options. So if the call is in the money, call is in the money, then we are going to pay the strike and then obtain an action and then sell the action. So minus k st plus so st. Okay, I'm gonna explain what that plus meant. And if the call is out of the money, well, it's gonna be zero, because we don't want to pay a strike just to then sell for less money, because we're gonna lose money. We don't execute the action because otherwise we would lose money. Okay, so I mean, so if this is positive, so this is profit, then we do this. If it's negative, then we do this. So this is just st minus k plus, and this is just a notation for what's basically over here. This is just let's see, this is just maximum. Obviously we're trying to make money, so we're interested in maximum. St minus k 0, whichever is greater. Okay, just a notation. It's simpler to write it like this. Oh no, that's bad. There we go. Okay, we want European. We're talking about European options. Now let's just, yeah, the value of a put. So this is just to add some context. This is gonna be call, European call, European call option, call option, with maturity date equals to t. Okay, just to clarify. Where are you? There we go. There we go. All good. Nope. Okay. And this is all gonna be, let me hide this one too. Well, maybe not that much. And to stress. Okay, the value of a put at time t is going to be equal to, if the put is in the money, so if the put is in the money, we're gonna if the put is in the money, then, well, first of all, we need to have an action to give, right? So we buy an action, the underlying, and then so yeah, we lose st, and then we execute, and we execute the option gaining the strike price. Okay, so we force the writer to sell the asset. We force the writer to buy the asset at price k. Okay, and then if it's out of the money, we don't make money. Okay, very simple. Okay, this is all clear. Okay, so let's look at yeah, I'm recording. Let's look at two portfolios, and just to finish, so the value is gonna be K minus ST plus. By the way, in a market, obviously the ST will be the same. It's the same in both expressions. Often in the context that I've seen, the K is treated as the same for put options and call options. I'm not entirely sure why, but it didn't have to be that way. I don't know if the NAP principle somehow implies that it should be the same, but it a priori didn't really have to be that way. So, okay, European options, value of call at T is ST minus K. Okay, and the value of a put at T equals K minus ST. This is a plus. This is a plus. Okay. Now we want to find two portfolios that have the same. Let's say we kind of let's put some notes here. We have two portfolios. Let's say in A. So obviously they're kind of the negative of one another, right? Okay. So we're basically going to compare the positive one with the negative the other, right? Because then we would obtain basically minus KST plus, which is pretty similar. No, actually, if we had the negative, these are, we could do the negative, but let's not actually. Let's do something else. So if, well, let's notice kind of cool thing, or not. Let's just first notice one cool thing, okay? Which is, well, a good, whatever. We can draw it, we can write it, doesn't matter. Imagine that, so this is gonna be S of T, okay? And let's say that this is just K. Sorry, it's gonna be ST. This is gonna be ST minus K plus, and also the K minus minus. Okay, so this is just ST equals K. So from here, as so here it's 0, because if ST equals K, then both are 0. Now if we start increasing ST, this is just literally the identity of ST, but then it's 0 here, right? And then, so maybe I can cheat a little to make it smooth and write this, whatever. Okay, and this one, well, here it's also going to be 0. I'm cheating, it's just supposed to be 0. But when it's negative, it's the identity, right? No, not quite right, sorry. It is actually the negative. Okay. So what does that mean? That means something that's also kind of obvious algebraically. It's pretty obvious, but whatever. Everything's obvious. What isn't? That ST minus K plus minus k minus st plus is equal to st minus kt, which is constant, okay? So that means that this is the value of a call at t, basically, and this is the value minus the value of a put at t, okay, is equal to, well, it's debatable whether this is a constant because of the dependency on t, okay, but okay, so let's try that. Let's say that our portfolio is to buy a call and sell sell a put, okay, and sell a put. Now if you notice, so t equals 0. Let's organize this. Let's calculate the values. That's what I want, okay? So value at t equals 0 and value at t equals, I am not writing the portfolio B yet, and at t equals maturity date, and this is portfolio A. Okay, so at t equals 0, the price of the call is going to be the value, the price and the value when you make the buy is the same. So this is going to be price of the call at 0, and then the value is going to be minus, because I'm gonna pay for it, and then plus the sell put, which is gonna be, okay, the price of the price of the put, which I'm gonna get. Now at the end, so if it's, so let's assume that if it's in our favor, okay, we're gonna exercise it, and it's gonna be this. If it's in their favor, they're gonna exercise it, and it's gonna be that, okay? Or here, let's assume that we have them, actually. If we have them, then we can immediately sell them and make the profit of whatever the price is. So I assume I already have a call. I assume I already have, I already sold a put, or like there's a put that I wrote. It's not that I sold, but so it kind of is. But let's assume that there's a put that I wrote, and I could sell that put to someone else. I can sell my I don't know what to call it. It's not my position, but my stance as a writer. Okay, and the value of that is this. That's the value. We know that at t, that's their value. Okay. Now I believe when there's no interest rate, we can assume the two are equal. But I'm not entirely sure. But I mean, I don't see any alternative to that. So anyway, we usually compare it to a pi b of someone who simply, there's going to be a person that happens to have st minus k money in their bank, okay, and they end up with ST minus K money in their bank. No interest rate, so there's no adjustment. Okay, and they're equal here, so they're equal here. Okay, I think that's how it goes. Now there's only one issue here, because this assumes the rationality of the holder of the put we sold, or the put we have, okay? Or the put we wrote, rather. Okay, because if they're irrational, then we could both execute our call and make money, and then they would also, so we could both execute our call and make money, or if our call is not in the money, but their put is, they could decide to still execute their put, which would actually give us money, which is nonsense. We're just going to assume that their rationality. So here, some crazy person in the world happens to have exactly ST minus K in their bank. Okay, now I think there's a trick we usually apply to avoid the sketchiness of the fact that this, in a way, kind of assumes the rationality of the other person, which a rationality that is forced by the NAP principle. There's a redundancy again, but whatever. There's a way to kind of cast those doubts away, which is we can actually pass things from one portfolio to the other, and that'll preserve the equality of their value at all times. Okay, so here, let's say that we buy a call, okay, and we could even, so let's, okay, what I'm saying is we can pass a sell put to the negative. The negative of sell a put is sell a minus put, which ends up being actually buy put. Okay, and we have a negative here. Let's even pass the K. Have K dollars or euros in your bank. Okay, and then here we're gonna have ST dollars in your bank. Okay, so we just happens to have that. Okay. Now I'm gonna copy this little thing over here. 22 minutes. We're fine. We're fine. Okay. Let's make this. This is completely different. No relationship between the two. Here, value of t equals 0, value of t equals t. Let's kill all of these. Okay, so in this situation, I buy a call, therefore it's the price of the call at 0. The call has maturity date t, I can add it, but whatever. And these put the maturity date t at 0, and then I have k plus k, and then plus st, and this one is going to be s minus k plus, actually it's useful to look up, s minus k plus, and here we have k, so plus k, and here it's going to be s minus k, sorry, k minus s, plus st. Okay, it's gonna be st, by the way. I was trying to think of the best way to show these are equal. I mean, one obvious way is like, if this is positive, then above we're gonna get, let's call them auxiliary. then obviously the top one is going to be, if positive, it's going to be st minus k plus k. The bottom one is going to be 0 plus st. Okay, and then if negative, this one is be 0 because it's out of the money, so it's 0. Options out of the money are 0, right? When we buy them. So plus k, and then this one, if this was out of the money, the bottom one is going to be in the money. So it's going to be k minus st plus st. Okay, so this is going to be st, this is going to be st, this is going to be kk. Okay, so these are equal, and therefore these are equal, and therefore we see t0 plus k is going to be equal to v bt 0 plus st. Woohoo! Yeah. Let me just, I want to give another proof of this. By the way, this is it. This is all that I wanted to do. For European options with the same maturity date, with the same strike price, obviously of the same underlying, we have this strong relationship, which also shows the power and is an application, is an example of an application of the NAP principle, and in a way the one price, the poop principle. I know I'm saying principle twice, I don't care. I'd also say the poo principle, but that's even worse. Or pop, I should call it pop. Anyway. Yeah, I'm gonna do, that's it, video over. But I'm gonna do a little proof of the other guy. So what we're saying is, I want to show these two are equal, okay? That's what I'm trying to show right now. So the maximum of st minus k 0 plus kt, but plus k is going to be equal to the maximum of st minus k plus, oh sorry, I'm going to go below. It's going to be equal to, the cool thing is in a maximum we can insert the same thing to both sides. That's a pretty cool thing. That's why I put the maximum here. St minus k plus k, and this is equal to maximum of st k. This is okay. This is actually really good. You see how symmetric this is, right? Anyway, this is gonna be equal to nothing weird, maximum of, so if we did this, we just have to do the opposite, right? So of 0, if we pass the s to the outside, k minus st, plus st, okay? Like I wanted, woo, right? So you can either think of maximums, or you can think of a binary thing where it has a value of positive and another of negative. Is there anything else that it's worth? I think there's another way that I wanted to prove it. I can't quite remember. I'll try and see. Okay, I want to go eat, so let's just try this. I want to basically use these two. How did I do it above? Oh, there's multiple ways. God damn. But basically, well, let's say this. St minus kt minus, so plus, I don't know if I already did this, but whatever. There's no kt. S minus, this is equal to, so just in other words, minus k st plus, this is just equal to s minus k. Okay. Which, I mean, basically already gives us what we wanted. Yeah, I already did this sorta. but it's just gonna give us what we already want, and as a result, st minus k plus plus k is gonna equal k minus st plus st. Okay, so proof. You could also, I guess, make the observation that st minus k, so st minus k plus, oh sorry, plus k minus st plus just equal to st minus k plus, which is not that unobvious either, if you consider the two functions. Or maybe it actually, it's not the most obvious way to think about it. But anyway, I'm happy. Here's what I wanted to do. Use the nap to derive the value of call and put actions at time 0. Let's establish a relationship between the two of them. Okay, so one version of the nap is the poop or the pop, whatever. And that gave me exactly what I wanted. Another day, I'll do the American options.